The focus of this presentation is to let you understand the theorem if a line segment joining 2 points subtends equal angles at 2 other points on the same side of the line segment, then these 4 points are concyclic, lie on the circumference. This is the abbreviation, converse of angles in the same segment equal. Right. Now, understanding the converse of angles in the same segment equal theorem, we are saying the diagram itself, here are 4 points, 1, 2, 3, 4. So this is the chord subtending these two angles, right? So if that is the case, then we are saying all the 4 points are on the circle or on the circumference. That means they are concyclic, right? Now, the given simply represents the hypothesis, a line segment subtending two equal angles on the same side. That is what we are given in diagram. This is a line segment. It's subtending these two angles that are equal. Then we are saying 4 points lie on the circle. That means 1, 2, 3, 4 should be on the circle. That is concyclic. Now, we need to understand something here. Line segment joining 2 points subtends equal angles at the 2 other points on the same side of the line segment. That means we have A, B, C, and D are the 4 points. But we are saying, as you can see in the diagram, any 3 are not collinear. Collinear, that means they are on the same line. They are not. We don't have such a situation, both A and B, B and C, and nothing. Any 3, we don't have any 3 that are collinear. AB subtends equal angles at C and D. That means this AB this angle is equal to this one. We are already given. That is angle ACB and ADB are equal. Now, what are we required to prove here? A, B, C, and D are concyclic. That means these 4 points lie on the circle. That is what we want to prove. Let us have some thinking here. We start with an end in mind. First, think in terms of the end. A, B, C, and D are concyclic. That is where we want to arrive. Number 2, think in terms of the start, the given. What theorems or properties can you deduce from the given? Create a problem, right? Because looking at these points or this diagram as it is given, there is no any other property or theorem you can come up with here that will help you prove that A, B, C, and D are concyclic. So we are going to create a situation that will lead us to conclude that. So since A, B, C, and D are non-collinear, let us draw a circle passing through A, B, C, and assume it does not pass through D, right? This is the situation. Circle intersects AD and E. So A, B, C are on the circle, and we have assumed that the circle does not pass through D. But then AD, we have an intersection at E, okay? If that is the case, we then use angles in the same segment equal and exterior angle property to get to the end. Because you can see that this is the circle, and a chord A, B is subtending the angle at C and E. So that angle at E, this one is the same at C, right? Then the exterior will come when we are going to use the triangle DEB. That's the triangle we are going to use, right? So to prove that now, we start by saying angle ACB, this one is equal to angle AEB, right? Angles in the same segment equal, that means subtended by the chord AB. But if we look at ACB, we are told that it is equal to ADB, right? So ACB is equal to angle ADB. This in C and in D, they are equal. That information is given to us in the problem, right? Then, so if you look at AEB, right, and this one, then I can substitute this AEB where there is ACB, what if I've done here. Then this ADB is still ADB. I have not substituted this. I only substituted this by this one to get this one, right? It's by transitive property of equality, because we are saying ACB is equal to this, ACB is equal to this, then AEB angle should also equal to angle ADB. Right. Now, if we consider now triangle BDE, this smaller one with a side which is dotted, all what it means, we can come up with the angle AEB, that is the exterior to that triangle, is equals to the sum, the angle in D and angle in B, angle in EBD. EBD, we are adding this one and this one to get our exterior angle, this one. This is what we have here, exterior angle property. Then, if we do that, you realize that the angles in green, they are the same. Why? We have BDE, referring to angle in D. But we can refer to that angle in ADB, referring to the same. But otherwise, the letters are different, but they are all referring to the same angle. So angle BDE is the same as writing it as ADB. This one is still the same, and this angle is going to be substituted by this one because it's equal to this one, isn't it? Then this comes here. So we have this expression, we are saying from 3 and from the diagram, because the way this is written, we can simply write it this way, which is one and the same thing. So having done that, you realize that if I take this to put it to that other side, it subtract, then I will remain this to the right-hand side. And this reduces to 0. So angle EBD is equals to 0. What is the angle EBD? EBD is 0. That means this angle is not there. If it is not there, then this arm or leg is not there. That means the D will coincide with the E, right? So at the end of the day, we are saying E and D coincide. That means E is equals to D, because we are saying this angle EBD is 0. That means it's not there, right? Therefore, our assumption was wrong, which implies that D lies on the circumference, which is the circle. Thus, A, B, C, and D are concyclic. Proof is complete. Key takeaways from this presentation: always start with an end in mind. This leads to the creation of a problem, drawing a circle passing through points A, B, C, and assume it does not pass through D to prove that A, B, C, and D are concyclic, right? So this is the diagram we have. From this diagram to this one, creating a contradiction. The use of the theorem, angles in the same segment equal the angle, the exterior angle property, is instrumental in this proof. Thank you very much.